Hi everyone, in this video, let's talk about reducing complexity in formal verification. Reducing complexity is an important part of getting closure in formal verification because a lot of time design can become very complex for a formal verification tool. We'll understand this using an example here shown here. In this example, you have a flop here. This flop is running on divide by 2 clock, while the launch flop is running on this clock. So the launch is running on a faster clock and capture is on a slower clock. In order to not have a data loss, typically what designers will do is basically they will have a mux sitting in front of the pin and only enable new data every alternate cycle to ensure there is no data loss. Now, this can be simply implemented by a driving select from a logic which works like 1, 0, 1, 0, 1, 0 kind of mode, where basically in one cycle new data is enabled, in another cycle new data is not enabled. So you want to ensure in order to for this design to work perfectly and not have data loss, this 1010 kind of pattern is followed. And this can be verified by writing an SVA in formal verification, which a formal verification tool can prove. Now, this is all good and valid when the logic is simple. Now think, even if the logic becomes complex, let's say I've changed this inverter to AND gate, and one of the input of the AND gate is same inverter, and then additional inputs are coming from somewhere else. So output of the AND gate is going to be 0, and basically when this input is going to be 0. So even if, let's say, if this signal is 1, in the next cycle it will get inverted and will become 0, and in next cycle it will become 0. So the logic still holds, and basically not having two consecutive ones still hold for this select. Now in this case, this logic had just an additional signal A. This A can only take value 0 or 1, but it can be driven from a more complex logic, which is basically A, B, C, D, all kind of combinational logic can come into the picture. But still, the property which needs to be proven is when in one cycle it is 1, the next cycle output is going to be 0. Okay. Now, this can be even more complex where you can have flops in between, FSM in between. All these complex logic can come into the picture. And let's call this complex logic, let's say a function f. Output of function f is always going to be 0 or 1, right? So now there is a way, let's say when formal verification tries to prove this, f can be really, really complex and a big equation, but the value output of that is going to be 0 or 1. But for us, the signal of interest is this signal here, which will define actually whether the property or the verification holds true or not. So we can abstract out f. What is meaning of abstract out f? Rather than asking formal verification tool to keep the complete Boolean equation for this, we can just say, okay, create a cut point here, and let's call this cut point this point, and this point can take value 1 or 0. Any value can be taken. Now the thing is, it becomes now similar to this. Whatever may be the fan-in logic of this is going to take value 0 or 1, and it makes it now easier for a formal verification to prove this either as a fail or a pass, whatever that happens. And this we are able to do because we know, right, our verification holds true because of this signal. If the verification was not possible without bringing in this logic, then this will not work. So this is one of the way we can reduce the complexity in formal verification. Of course, there are other methods as well, which we will talk in subsequent videos. I want to make an important announcement. We, MetaVLSI, is launching a formal verification internship program. This will help you gain real world skills with expert mentors in our dynamic learning environment. The benefits of this training or internship is you will earn stipend while on the training. There is a guaranteed job offer after successful completion, and this will allow you to become an expert in formal verification. The eligibility for this is any EC, BTech, or MTech can apply for this, any experience level, even if you're a fresh graduate. The requirement is that you should have completed training or internship in DV, which can be normal DV or formal verification DV. And if you're interested, please apply to this email ID. If there are any questions, please feel